Hello everyone, how are you going? Back here for some questions in spec. Now these are some really good questions in that they make you think. There is a whole range of these sort of sketching on the Argand plane questions. Do as many as you can, because the one that you don't do is the one that will come up in the test, and then you think, I have no idea what I'm doing with that. Once you've seen a good number of these, you generally look at them and go, I already know what that looks like. I do that with this one, but you might not yet. Let's work it through. This is saying the set of points of z, the complex number z, such that the absolute value of z, or the modulus of z, think r cis theta, so it's the r part, is equal to the argument, think of the cis theta part, or the theta part, of z. So it's the same complex number we're talking about. And what we're saying is that the value of it, the modulus of it, has to be equal to the angle of it. So the modulus has to be equal to the angle. Well, as I go around here, my angle is increasing, isn't it? So if these two have got to be equal, as this one increases, so must this one for the set of points. So think about that. As I go around, the angle increases, and therefore the set of points that I want that fit this are also increasing. That's going to be a spiral. So let's do a couple of points. At 0, angle of 0, the complex number that I want is really going to be 0 plus 0i. That's not really a complex number. You can't have that. But the absolute value of that would be 0 as well. So it would be kind of right here. We'll come back to that in a minute. At, say, 45 degrees, or actually let me jump to 90 degrees. At pi on 2, when I put pi on 2 in there, or actually rather the whole thing is equal to pi on 2, that means the point that I want is when the absolute value also equals pi on 2. Well, if this is 1, 2, 3, then pi on 2, what's that, 1.6-ish, 1.5 and a bit? That's going to be there. So the angle would be pi on 2, and if I get the right distance away, then the modulus would also be pi on 2. Coming around, no, that's correct. I was thinking that, don't worry, ignore it. I just thought I made a mistake. Then we've got over here, we're around at pi. So when I get pi out of here, this needs to be pi. So what's that? 3.14. I haven't done this, scale this up very well. I'm going to be here. And then down here, I'm going to be down here somewhere. And when I get back around to here, I'm going to be at 6.28 or 2 pi. So isn't it going to be, I don't know how well I'm going to do this drawing, going to be something like that, and then around there. So it's actually going to be a spiral. Now let's talk about this point at the middle here. We can't actually get a 0 plus 0i. What is that? Well, that's nothing, isn't it? That's right here at the centre. We can get the modulus for that, because it's just 0. But you can't get an angle for a 0 complex number. So I actually think we probably should put a circle there, an open circle, to say, well, actually, we're not including that one right there. Anything outside of that is okay, but that's not. So again, looks complicated, simple solution if you know what you're looking for. All right, this one here. Z such that Z is equal to cos theta plus I sine theta. Hopefully you straight away realise, that this is just cis theta. And then if you also realise that there's a 1 and a 1, it's really 1 cis theta, isn't it? And really, whatever the value of that is, the modulus is always going to be 1, isn't it? Doesn't matter, the modulus is always 1. So in fact, this is actually just a circle of radius 1, because the angle doesn't really matter. The modulus is always going to be 1. So maybe I'll make these the other way around. Yeah. So really, it's just going to be a circle. Oh, a bit dodgy over here. It's just going to be a circle of modulus 1. Now, because it's equal, that's all we need. Less than to be inside, greater than to be outside. Greater than or equal to, include the line. Easy, see? Right, this one, this is a bit chunkier. This you might not have seen of yet. Hopefully you have. It's just the set of complex numbers. Just like we have R with the extra line in it for the set of real numbers, that's the set of complex numbers. X such that it is the set of complex numbers. Right, it's a cubic equaling 0. So probably the first thing I'm going to do, I'm just going to say, well, I'm going to rewrite it as f of x rather than the 0 equals x cubed plus 1 plus I x squared plus 2 plus I x plus 2. Now don't get confused at these. These are just coefficients of the terms. There's nothing special about them. They're complex, but nothing special. Okay? These are just the coefficients. Now what I'm going to do is I'm going to try and rock on through and pick a number that will give me a 0 point. Give me an x-intercept. Now I kind of cheated. I know -1's going to work, right? So if I go f of -1, follow it through. Hopefully it does. Hopefully I did get it right. That's going to be -1. That's going to be +1, right? So therefore just multiplied by that, it's going to be +1 plus I. That's going to be -1. So isn't that going to be -2 minus I plus 2? And hopefully you can see straight away there that clearly the i's are going to cancel out. That one's going to cancel that. That's going to cancel that. Bingo. Okay. So we know that -1 gets us 0. Okay. So -1 is the solution. Therefore, x plus 1 must be a factor of that. -1 is the solution to. Therefore, x plus 1 must be a factor of. So I must be able to write something like that. Because remember, put -1 in there. That would be 0. 0 times anything must be 0. Alright? Now what will we fit in here? Well, do this. Just look at it as ax plus b, or sorry, ax squared plus bx plus c. Okay? Now, these two multiplied here will give me the last term. But be careful, because of complex numbers, there might be a chance that two complex numbers multiply, giving us a real. But usually, these two give me this. Here, won't I get ax cubed out of that? Ax cubed, and I know I only want 1 x cubed. So straight away, doesn't that mean that a must be equal to 1? That's the only way, this is the only spot I will get x cubed, and I only want 1. So I think a's got to be 1. Now let's check, say, the x squareds. Where are we going to get them from? Well, from there, I will get an x squared, and from there, I will get an x squared, won't I? So couldn't I write bx squared plus ax squared must equal 1 plus I x squared? Now if I factorise this left-hand side, isn't that b plus a x squared equals 1 plus I x squared? We already know a is equal to 1, so b must be equal to I to be able to get the other part of it happening. So I reckon b must equal I there. Right? Now then I can take those, put them in here, use the quadratic formula, factorise that, and I will get the other two solutions to it, or potentially other two solutions. I'm running out of a bit of board space here, I'll leave that with you, but we take these, put them in here, factorise that, we should get two other solutions, and then this is one of our, -1 is one of our solutions, and then whatever the solution from there is, would be our other two solutions. Funky questions. I hope you've enjoyed this for a Friday. Have a great long weekend. Catch you next week. Bye for now.